All right, we're looking at another, I'm going to adjust my camera here a bit. Looking at another plane problem here, descending airplane problem. We've got that this airplane is at 18,000 feet as it passes over town A. It's a very boring name. And it's at 10,000 feet as it passes over town B. And we're going to call, I guess I called this Lincoln down here. Okay, well, town A. Okay, town A. So we are, the x-axis on our graph represents distance from town A. So as we're passing over town A, we are 0 miles from town A. And the y-axis represents our altitude. And you can see as we're crossing over town A, our altitude is 18,000 feet. As we cross over town B, which is 240 miles from town A, we are at 10,000 feet. The question is, how far will we be from town B when we finally land? So I know what we're going to do here. Oop, I need a ruler. Okay, got my ruler. So again, we're going to do kind of what we've been doing, is we're going to write an equation for this line, and then use the equation to figure out where the x coordinate is. That's our distance coordinate. Where that is when the altitude, the y coordinate, is 0. So I'm going to kind of draw a line here that passes through these 2 points. Kind of get an idea of where we're at. This might not be super accurate, so. Alright, so it looks like we're somewhere out here. Let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4. Here's 500. 1, 2, 3, 4, 5. Here's 600. I'm going to extend my axis a little bit here. So maybe it looks like we're at 540 maybe. All right. But to be sure, we're going to have to write our equation out. So to write our equation, first thing we need to do is find slope. Okay. So let's see. Our change in y, and we're just going to imagine that we're going to the right, makes things easier, is end minus start, tells us what our change is. So we end at 10,000, we start at 18,000. So 10,000 minus 18,000 is negative 8,000. Our change in x is end minus start, so 240 minus 0 is 240. And remember, this represents negative 8,000 feet, and this represents 240 miles. Keeping in mind that the 240 miles is distance along the ground, and the 8,000 feet is an 8,000 foot drop going down. So we're going to be looking at feet down per mile forward. That'll be our rate. So change in y over change in x is negative 8,000 over 240. I don't feel like doing that in my head, so I'm going to get a calculator. All right, I have my calculator. So we had, let's see, negative 8,000 divided by 240 gives us negative 33, and 3 are repeating. So I'm going to do this as negative 8,000 ABC 240. That gives us negative 33 1/3, which I'm going to turn into so negative 100/3. So I'm going to write this first as a reduced improper fraction, and then I'm going to write it as, all right, this is kind of easier for us to deal with in a lot of situations, but this is like kind of a number that's a little easier to understand, so I'm going to put both representations here. So now we know our slope, so now we just need to write our equation. So our equation, we're going to use slope-intercept form because we know our intercept. So y equals our slope, which is negative 100/3 x, plus our intercept, which is 18,000. Okay, so then we have our equation. And finally, to figure out where we are when we reach the altitude of 0, Well, our output is our altitude on this, so I'm going to replace y with 0, and then we'll solve the equation. So I'm going to put find distance from town A at 0 altitude. So then we just plug in 0 equals negative 100 thirds plus 18,000. I'll subtract 18,000 from each side, equals negative 100 thirds x. And then I just have to divide both sides by negative 100 thirds. So I'll do that with the calculator. 18,000 divided by negative 100 ABC3 gives us negative 540, kind of where we thought it would be. Oh, this, by the way, should be negative, so it should be positive 540. So 540 equals x. Okay, so that's a distance from town A, but we want a distance from town B. So over here, find distance from town B. And so the town B was, as we see here, 240 miles in already. So it's 540 minus 240 equals 300 miles. So we're 300 miles from town B. So just to go over what we did here, first, we kind of graphed things out, got an estimation of where we'd probably be. Then we were going to write an equation that represents the plane's descent, with the input variable being distance from town A and our output variable being the altitude. So we knew that at 0 minutes from town A, or 0 miles from town A, we were at 18,000 feet, and that at 240 miles from town A, we were at 10,000 feet. So we used that information to set up our slope. Then we wrote an equation in slope-intercept form after we found the slope, and we knew the intercept that was given to us in the problem. Then we just had to substitute in 0 altitude for y, solve for x. We got 540 miles, which is where we anticipated it would be. Hello, morning! And, and then, so that's where we knew how far we were from town A when we landed. But then we had to subtract the 240 miles that we'd already done into town to get to town B to find out how far from town B we were when we landed. We ended up with 300 miles. Right? And that's how we find the distance from town B when we land.